Good morning. Today my group will be presenting about how physics is connected with the art and culture of Odisha. Odisha is an Indian state lying along the country's east coast. It was also the battleground for the famous Kalinga War, which later transformed Emperor Ashoka into a stable and peaceful emperor. This marvelous state is known for its stunning architectures, history, dialects, vibrant art, music, and dance forms. When the sun rises here, it rises over a land of temples thriving on top of a solid foundation laid by Odisha's heritage. In this presentation, we will talk about the cultural and architectural wonders of Odisha and how they are connected with science, mainly physics. Now, my partner Kirti will talk about the musical instruments of Odisha.
Music is intertwined with the social fabric in Odisha. The dainty dancers and musicians depicted in the temple architecture are a testament of glorious musical traditions, whose legacy is an important element in our cultural heritage. Be it in any function, activity, or social gathering, music is omnipresent. Diverse lifestyles and social customs have shaped the musical scape of Odisha, which is distinct yet soulful. First, we will be looking at Mardala, a percussive instrument. This instrument is native to Odisha and it is traditionally used as the primary percussive instrument in the ancient classical music of the state. This is how the Mardala sounds. To understand how this sound is created, we will see the working of the instrument. Sound gets generated when the leather surface is stroked. The waves thus created reflect from the leather surface, producing standing waves. There are various air levels floating over the instrument. When the leather surface vibrates, air levels also vibrate, pushing the adjacent levels in the upward direction. Hence, the layers start pushing the other floating air levels, causing their compression. Subsequently, this compression starts to travel in the air. Meanwhile, the leather surface loses its tension and returns back to normal. Air layers on it thus expand and the pressure is released. When this leather surface attains its original position, this expanded air level is pushed upwards. Thus, the pulse due to the compression and expansion begins to travel ahead. As this pulse is dependent on the vibration of the leather surface, its frequency is similar to the leather surface's frequency. In this way, the vibrating air layer reaches the listener and they are able to hear the sound.
Now let's look at the Mahuri, a traditional wind instrument belonging to Odisha which is considered Mangala Badya, that is auspicious instrument. It is an instrument having double beating reeds and 7 fingering holes, a metallic bell attached in front. It is blown through the reed. Here is how the Mahuri sounds. After hearing the sound of the Mahuri, you must be curious to how it produces it. Let's look into that. The Mahuri is an instrument that acts like an organ pipe open at both ends. The two open points of the flute are pressure notes, which basically means the amplitude of the sound at those points will be zero. The frequency of a standing wave is determined by the formula F is equal to Nv upon 2L, where V stands for the velocity of the wave, F stands for the frequency of the wave, L stands for the length of the air column, and finally N stands for all positive integers. When we open a hole, it is similar to shortening the length of the pipe as the hole in quotes short circuits the Mahuri and a standing wave will be formed between the open end where we place our lips and the first hole. Similarly, opening different holes will generate different standing waves with different frequencies, corresponding to different n depending on which holes are opened. This is necessary to create different notes of sound on the instrument. Thus, by opening and closing different holes and controlling the pitch of the air we blow in, we can produce a melodious sound on the mahuri. Moving on from the musical instruments of Odisha, now let's look at the Hirakud Dam. It is the longest earthen dam in the world, extending to about 55 kilometers long. It was built in 1945 and it is still an impressive feat of architecture. It stops the flow of the mighty Mahanadi River and uses its water to generate hydroelectricity. It was also one of the first major multi-purpose river valley projects started after India's independence. Let us look at how the energy is created. In nature, energy cannot be created nor destroyed, but its form can change. For the same reason, when generating electricity, one form of energy is just converted to another form. To generate electricity, water is set in motion. This is known as kinetic or moving energy. When the flowing water turns blades in a turbine, the kinetic energy is changed into mechanical or machine energy. The dam creates a head or height from which the water flows. A pipe, also known as penstock, carries the water from the reservoir to the turbine. The fast moving water pushes the turbine blades, somewhat like a pinwheel in the wind. The water's force on the turbine's blades turns the rotor, which is the moving part of the electric generator. When coils of the wire on the rotor sweep past the generator's stationary coil, also known as the stator, electricity is produced. This concept was discovered by Michael Faraday in 1831 when he found out that electricity could be generated by rotating magnets within copper coils. The water used to generate the energy then flows unchanged to serve other needs. The turbine turns the generator rotor, which then converts this mechanical energy into another energy form, that is, electricity. Since water is the initial source of energy, we call this form of energy hydroelectric power or hydropower for short. Hydropower is generated in facilities known as hydroelectric power plants. Some power plants are located on rivers, streams, or canals. But for a reliable water supply, dams are needed. Dams store water for later release for purposes such as irrigation, domestic, industrial, or power generation. The reservoir acts much like a battery, storing water to be released as needed to generate power. This is how a turbine looks.
Here you can see the generator stationary coil, also known as the stator, and also the generator's rotor. And at the bottom, you can observe the turbine and the blades through which water flows. I hope by now you would have understood how hydroelectricity is generated and also how a turbine looks. A sundial is a device that tells the time of day by measuring the apparent movement of the sun accurately. In Orissa, sundials were mostly constructed during the British period. Historic sundials are found at Bhubaneswar, Cuttack, Konark, etc. The simplest sundials consist of a dial and a shadow caster known as the gnomon, which casts a shadow onto the dial. As the sun appears to move across the sky, the shadow aligns with different hour lines which are marked on the dial to indicate the time of the day. The gnomon usually casts a broad shadow so that it is easier to see. However, this can lead to uncertainty over which side of the shadow to read. To avoid this, one side is usually curved and the style will be a straight line which lines up with the hour lines. The style of the gnomon must be parallel to the axis of the earth for the sundial to be accurate throughout the year. Therefore, the style's angle from the horizontal is equal to the sundial's geographical latitude. Thank you. I hope that, like Shiab and me, you would have also seen how physics is hidden in the wonderful culture of Odisha.